Okay, so this is kind of a simulation for sine and cosine. You notice the sine here. Sine is it's the y coordinate, so that's why it's the turquoise. It's the length of the turquoise line here. And the cosine is the x coordinate, which is, the horizontal distance, so it's the length of the purple line here. These two dots are going to represent where cosine is. So, for example, the length of this purple line is exactly the height of the pink dot up on the top here, or the height of the turquoise line is exactly the height of the turquoise dot. And so as we move around, those dots are going to change positions, right? So as we move around, and I have the trace on, so it'll actually kind of keep track of where it is. So let's go back to the beginning. Here, this is 0, right? So at 0, sine is in fact 0. At 0, cosine is in fact 1, because the length of the purple line here is in fact 1. So what we're going to do is we're going to play this, and you'll notice the sine and cosine curves being created by those dots. Please, note that the length of cosine right now is shrinking, and at the moment it is 0, and hence that's why the cosine actually crosses the x-axis there. And same with sine, so sine's coming down to 0 here, crosses, and now it's below the x-axis, and so that's why the sine dot goes into the negative. And so, so let's just watch this once. I'll play it again, just for you to see exactly what's going on. There we go. And then once it reaches the circle, it just starts over. And this is all based on the angle. My x-axis, I haven't put any pi on there, so 2 pi is, a little over 6. All right, so those were a little easy. Those are kind of easy ones to imagine. So let's now imagine tangent and cotangent, though. Those are a lot trickier. So I'm going to reset this. Reset how this looks. This might take me a second, but so let's do tangent. Let's just do tangent first. So that's your tangent dot. I also am going to want the tangent line. And the tangent line, okay, so that's going to be our tangent line. Now, the tangent line comes from, let's see here. Nope, not that one. Sorry. Let's do there we go. Okay, so that's our tangent line in gray, right? And so notice, I'm going to actually turn off the cosine and sine lines and dots, in fact, as well. So we shouldn't see any cosine and sine. We're just looking at tangent right now. So notice how, as this thing goes up, what we're doing is we're looking at, we're going to come back just a hot sec here. So as this thing goes up, we're looking at, well, where is my, where is the, let's see here. The line that goes from the origin and connects with the tangent line, where does it actually connect with this tangent line? It connects right here. And so that's why the tangent dot is actually at that exact height. And you can tell that throughout. So notice how the green line has the exact same height as the green dot. And so there's where we're kind of moving through. Now, obviously, it starts down here at 0 and just goes this way. When we graph it, we usually go into the negatives, but this simulation only goes forward from 0. So you'll just notice the next period, which is fine. So let's continue playing that. So it goes up, and now it starts over. But now, notice the line is actually going to hit. So at this point, when you're over here, so this line never actually hits the tangent line. So what we do is instead of going out this way, we reverse it and go the other direction. And if we reverse this line the other direction, it would hit the tangent line in the negatives. And so that's why tangent starts at the bottom here. As we go to angles past pi over 2, and get to 3 pi over 2 down here. So we'll continue playing now. And so here is our tangent curve. And that's usually all we do. We just do one of these, even though there's actually a little bit here, and we could even do, if we wanted to continue to 2 pi, we would get half of one over here and half of one over there. So I'm going to let that run again and try to get the so that kind of might help a little bit more, if you notice. All right, let's do the exact same thing. I'm going to pause this, and I'm actually going to keep tangent up, but what I am going to do is add a cotangent line. Let's get rid of tangent for right now, and let's play cotangent, which is going to be the exact same thing, except so we're going to have cotangent dot. We're going to have a cotangent line here. I think it's this one. We will see. Nope, that's secant. There we go. There's cotangent line. And yeah, so we'll start playing that at this point. So here's cotangent. And so the cotangent line, which is the red line, so that's now it's negative, right? Now it's negative, and it's getting larger and larger, and at some point it goes to negative infinity, which is why the dot went to negative infinity. Now it's coming back up, and so this is why we get this as our cotangent. So we notice cotangent actually starts up at positive infinity, comes down, and heads to negative infinity at pi. So we get these graphs for tangent and cotangent. Interesting. I'm going to let this run through one more circuit so you can watch, and then we'll switch to secant and cosecant. Okay, so let's do secant and cosecant. So I'm going to turn off the cotangent, and I'm going to also turn off the tangent. That looks like it did. Let's see. Okay, and let's see. Let's turn off this line, but include this one. Okay, so we're going to do secant this time. I'm pretty sure secant, yep, secant is orange. So on the orange one, let's make sure this is orange, yep. So on the orange one, secant, as we covered, is the reciprocal of sine. Or sorry, cosine. Secant is the reciprocal of cosine. So I'm actually going to turn back on cosine. Nope, that's sine. Turn back on cosine just so you can kind of see how those two react together. So I'm going to find the dot of cosine as well. That's it. All right, so let's play. And I'm going to pause it right about, let's go. Okay, so secant is the distance from the origin out to the tangent line. So this orange distance is actually the exact height of this secant dot up here. Notice how cosecant and cosine and secant is kind of like how we usually graph it, and so that's why I'm going to leave it up there. Now, secant doesn't actually hit, it hits in the negative, so that's why the secant line is actually negative at this point. And goes off to infinity, and now it's at negative infinity, or sorry, at positive infinity, and now goes to 0 with, or goes to 1 with cosine. Let's I will let that run through one more time. So whenever you have to go the reverse direction to hit the tangent line, the secant's negative. So it's negative right now. It's going to flip to being positive, right? Because we're going out the correct direction and actually hitting the tangent line. So it's positive now. It's going to be positive throughout this curve here. But then, right when we hit pi over 2, it's going to flip to negative. Because we can't hit the tangent line going this direction. We have to hit it going the opposite direction. So that's why it's negative. Okay, so that's secant and cosine. So now I'm going to switch secant out and cosine out, and I'm going to switch to sine and cosecant. There we go. So the orange is gone. I'm going to see if this is actually... Okay, so I think I have it. We've got the two. Okay. So let's start over at the beginning now. So we'll go back to this. So here's 0. And let's play. So again, let's actually pause that for one moment here. Let me switch these two lines out. I'm going to take that line. Oh, no, I want that line. I'm going to switch out the tangent line and put in the cotangent line. That's going to make it a little bit easier to tell what's going on here. So we'll go back to the beginning and erase. Okay, so what is cosecant? Cosecant is the distance from the center to the cotangent line. So in this case, cosecant is positive, and it started at positive infinity. So it's way up at the top out of your screen, but it's coming back down here. And when it comes back down, it's going to meet when both cosecant and sine are both 1. And where they are both 1 is at pi over 2. So by the time this dot gets to pi over 2, they're going to both be at positive 1. Where they meet at exactly that height. There it is. And now we switch to cosecant being negative, right? So, cosecant isn't negative. The cosecant is still positive here. It's being negative now because we can't. So cosecant is negative at this point because going out the positive direction will never actually hit the cotangent line, so we have to go out the negative direction. And so that's why cosecant is negative. It's also negative because it's going to be the exact reciprocal of sine. So when sine is, about negative 1/2 at this case, cosecant must be negative 2. So let's continue to play. They meet up at negative 1 and then continue on. I'm going to let this play through one more time. All right, so I'm going to let it play through one more time. So now let's just play this through with all 6 trig functions actually being graphed. This is, kind of intense, so we'll see if you can follow any of it. Let's do that one more time. Yeah, well, hopefully you enjoyed this. It's an interesting way to look